Okay, so this paper right here has all of the exponent rules on it, and it's going to help you keep things straight in your head. My advice to you is to go through and see if you can fill in the blanks for A, B, C, D, E, F, and G, and make sure that you don't already know it, and then come back to the video. You might even want to go ahead and try the examples, and you could even fast forward through the video to see if you're right, and then if you're not, go back and listen to the video again. If you are super lost on all of this, then you should just tune in the whole time. But the best way to learn from a video is to try things before you hear me say it, especially on concepts that you've already been taught. So that's my 2 cents there. All right, letter A. When multiplying numbers with the same base, you add the exponents. So that's what we're going to go through and we're going to do. So if you look here, you have the same base. The base stays the same. The base does not change. And then you add the exponents. So I would write to the A plus B. Here, I have the same base. They're both x's. And I can add negative 3 plus 5 and get x to the second. So the cool thing about that is the negative 3 and the 5, because you ended up with a 2, it's still positive. It's positive, so you don't have to worry about any negative exponents. For example 3, when you have that giant negative sign in front of a term, put a 1 there. This guy right here, that's a negative 1. So you're going to multiply 6 and negative 1 together to get negative 6. Then you're going to add the exponents on x and x to the 6. So that x has an imaginary 1 on it, x to the first. Add that together, it gives you x to the 7th. And then this little y to the right has imaginary 1 on it, y to the 4th and y to the 1st gives you y to the 5th. So now when taking another exponent to another exponent, with examples like 4 through 7, you multiply the exponents. So whenever you see that little exponent on the outside of the parentheses, when you bring it back in, you multiply it. So this example 4 would be x to the a, b. Example 5, multiply these together, you would get x to the 21st. Now the negative thing, I'm going to rewrite example 6 so that it's negative 1, x to the 6th to the 3rd power. Technically this negative 1 has a little exponent of 1 on it, so what you're doing here is negative 1 to the 3rd power. So that's technically like negative 1 to the 3rd power. And then here, multiply your exponents, it gives you x to the 18th. Negative 1 to the 3rd power is a negative number, so that's negative 1. So that's why my answer is negative x to the 18th. So it becomes negative. And if you want to write negative 1 there, that's technically fine, just not fully simplified. So now this next one, you have the negative 6. You've got this double parenthesis thing going on. So if you look, this guy right here, you should really take this to the 6th power first. So that's like doing negative 1 x to the 6th, the whole thing, to the 3rd power. Let's deal with the fact that you have a negative 1 being taken to the 6th power first. So it's like negative 1 to the 6th power, x to the 6th power, the whole thing being taken to the 3rd power. This guy right here, because negative 1 is being taken to that even power, that's going to be positive 1. So really what we have here is just a positive x to the 6th taken to the 3rd power, which now we can multiply those exponents to get positive x to the 18th. You also are welcome to multiply these exponents together first, and then you still have negative x to the 18th, which would still give you positive x to the 18th, because a negative taken to an even power, all the negatives will pair up, so you will always have a positive answer. Over here is a little different because you were taking it to 3 and a negative to the 3rd power. All the negatives don't pair up, so the answer is negative. So now, when there are multiple factors being taken to an exponent, apply the exponent to all factors. So we're kind of doing that on the last couple of examples in section B, but now we're going to make it more apparent. So in example 8, x, y, they don't have exponents on them, so you can imagine that there are little exponents of 1 on them. Every single number, every single variable has an exponent on it, and if it's not there, it's an imaginary 1. So you can always write that. So then when I bring it in, you're multiplying those exponents. 1 times a is a, so that's how I get x to the a, y to the a. So in example 9, we imagine there's an imaginary 1, so it's 2 to the first, x to the 7th. When I bring it in, I'm going to end up doing 2 to the 4th power because 1 times 4 is 4. X to the 28th power because 7 times 4 is 28. And then you do 2 to the 4th power, not 2 times 4, 2 to the 4th power, which is 16. So you get 16 x to the 28th. The next one, that -3, imagine there's a little 1 there. So technically what you're doing is -3 to the 4th power, x, multiply those exponents there, x to the 24th, y to the 16th. But then do -3 to the 4th power, and that -3 has to go in parentheses, which means you're multiplying the -3 4 times. So it ends up being positive 81. Now if you have trouble getting the positive 81, I like to write down all 4 of them and start pairing them together, right? So rather than doing -3 times -3 is 9, and 9 times -3 is -27, and then doing -27 times 3, I like to just pair them up, right? This is a 9, this is a 9, 9 times 9 is 81. So there you go. There's your answer to D. I mean 10. So now when you're dividing numbers with the same base, you subtract the exponents. And if when you subtract, you get a negative exponent, that means that that term stays in the denominator. So for number 11, you have the same base. The base is k. You don't know what the exponents are, but if you did, you would subtract them. So this would just be k to whatever h minus r is. Number 12, they have the same base. The base does not change. This is -8, and then you subtract your exponents. 50 minus 5 is 45, so that's -8 to the 45th power, not 1 to the 45th power. You don't divide the bases, because think again about what exponents mean. If you have -8 to the 50th, that means on the top you are multiplying -8 50 times. On the bottom, you're multiplying -8 5 times. So you're able to cancel out the 5 -8s that are on the bottom with 5 -8s that are up here. So you're left with 45 -8s. If you write 1 to the 45th, what that means is you're multiplying the base of 1 45 times. That's not what we're doing here. We're multiplying the base of -8. So keep that in mind. All right, so now the next one. 9 over 21, those aren't exponents. So you just treat that like a regular fraction, 9 over 21. So you can divide 9 and 21 by 3. So that's going to leave you with 3 on the top and 7 on the bottom. Keep it like that. If it's an improper fraction, keep it an improper fraction. And then you subtract your exponents here. M to the 5th over m to the 1st. 5 minus 1 is 4. So that's going to be m to the 4th. Now this you can look at 2 ways. You could do 2 minus 10 and get -8. Because it's negative, that means that there are more n's on the bottom. So you're left with n to the positive 8. The other way to think about it, n squared over n to the 10th, is that you have 2 total n's on the top. You have 10 on the bottom. You're canceling out the 2 n's on the bottom with the n's that are left on the bottom. So you've got 8 total n's left on the bottom when you cancel these guys out. All right, so now when a fraction is raised to an exponent, you do the same thing you would with the multiplication, except you've got a top and a bottom. So you're going to apply the exponent to the numerator and the denominator. So you have to make sure you're doing it to all the factors in the numerator and the denominator. All right, so for example 14, you bring that w to the top and the bottom, so it ends up becoming m to the w over n to the w. All right, the next one Imagine, these guys have little 1s on them if they don't have exponents, so you'll bring them in. So this would become m to the third over 6 to the third, and then simplify that. You should know 6 cubed is 216, so it's m to the third over 216. All right, example 16. The 3, the 7, and the g, you can put little 1s up there. So when you bring it in, you're doing -3 to the second power. I'm going to write it the long way down here. You can do that in your head, it's 9. G to the second power over 7 to the second power, h to the 6th. You multiply exponents, just like you do whenever you bring an exponent from the outside and you multiply the exponents. And so now, fully simplified, it would be 9 g to the second over 49 h to the 6th. The next one, put an imaginary little 1 on the 8, the 3, and the x if you need to. So when I bring it in, I'm doing 8 to the third, p to the 9th over 3 to the third, x to the third. So just keep in mind, we're not doing 8 times 3, we're doing 8 to the third, which is 512, p to the 9th over 3 to the third is not 9, it's 27, because we're doing 3 times 3 times 3, x to the third. Now concept F is getting into concept 12, which is negative exponents. So when a negative exponent is a factor in the numerator, which I say upstairs, it moves downstairs and becomes positive, or really, technically, we're going to say it moves to the denominator. My pen isn't working very well. To the denominator. And becomes positive. So that's what we want to do. We want to try to make all of our negative exponents positive. And to do that, all you have to do is move it where it's at. When a negative exponent factor is in the denominator, or what I like to say downstairs, it moves upstairs or to the numerator. And becomes positive. I'm just going to draw an arrow for it becomes positive. When a negative exponent is on an entire fraction, you don't have to bring it in, because as soon as you bring it in, it's going to change everybody's sign, all the exponents' sign, and you're going to move everything. So if it's on the outside of parentheses on the entire fraction, you flip the fraction and make the exponent positive. But that only changes the outside exponent to a positive. Okay? So now with example 18, this top k has a negative exponent on the top. So it needs to go to the bottom. And now if you're moving something from the top to the bottom and there's nothing else left up there, it's a fraction. You have to put a 1 up there. Otherwise it's not a fraction anymore. So this is going to become 1 over k to the r times k to the positive h. Now technically, because these guys have the same base, you can then combine the bases, combine the exponents by adding. So really, the most simplified version of this answer would be 1 over k to the r plus h. If you left it like that for now, I would take that. So now number 19, this guy is in the denominator. So you pop it up to the numerator and it becomes k to the h, k to the h times k to the positive r. It is over 1, but that's like dividing by 1, right? When you divide by 1, you just have the top. So we don't need that 1 there. You can drop 1s on the bottom. You can't drop 1s on the top. So because these guys have the same base, the technical correct answer would be k to the h plus r. If you left it as k to the h, k to the r, I would accept that as well. All right. Now make sure you're not getting negative numbers and negative exponents mixed up. So in example 20, negative 5 is a negative number. It technically has a positive 1 exponent on it. So imagine there's a positive 1 exponent there. K to the negative third, the k is what has to move. The negative 5 can stay right where it's at. So I'm going to move the k to the negative third downstairs. And so what I'm going to have is negative 5 over 15, and then the k to the fourth and the k to the third now can be combined. Notice when I move it downstairs, we combine things with the same base by adding the exponents. So that's going to give me k to the seventh. We also now, this is like a normal fraction, negative 5/15. We're going to reduce that. 5 goes into 15 3 times, it's negative 1/3. So you have to have negative 1 in the top, and then it's 3 in the bottom, k to the seventh. And so that's that final answer. Now, number 21 has a negative exponent on the outside. I'm not going to deal with that just yet. I want you guys to get in the habit of when you have parentheses, I want you to fully simplify what's inside the parentheses first, because the order of operations says to do that, right? The order of operations says do what's in parentheses first. We can do something here, right? 4/8 can be reduced to 1/2, and then my d's can trade places. So I'm going to put d to the positive fifth on the top and d to the second on the bottom. This whole thing, don't forget though, is being taken to the negative third power. You can go ahead and fully simplify the whole inside again. We can cancel out the 2 d's on the bottom to leave d to the third on the top over 2. Notice I got rid of the 1 because you don't need the 1 because you have d to the third at the top. And then you have negative 3 still. Now, to take care of this, you flip the whole thing. So this becomes 2 over d to the third, the whole thing, to the positive third power. So now imagine there's a 1 on that 2. So you're doing 2 to the third and d to the, you multiply the exponents, d to the ninth. So 2 to the third is 8, putting my answer up here, over d to the ninth. And there's your answer to that one. Now zero exponents. When a factor is raised to the 0 power, the result is always 1. Now, whenever you see a 0 power, it doesn't mean that the entire answer is always 1. It's the factor that is, it's the base that's being taken to the 0 that becomes 1. So in example 22, this answer is positive 1. The whole answer is 1 because the base of the 0 is everything inside the parentheses. It doesn't matter what 6 minus m is because as soon as you do 6 minus m, you then have to take it to the power of 0. And since the whole base is being taken to the power of 0, the answer is 1. Now this one, the only thing that has a 0 power on it is m. The 6 has an exponent of 1 on it. So technically what this means is 6 times 1. Well, 6 times 1 is 6. And this next one, the only thing that's equal to 1 is p to the 0. So this really is just negative 3 times the 1 inside the parentheses, which is being squared. So this becomes negative 3 to the second, which is 9. Another way you could do that is you could bring the exponent in first and do negative 3 squared, and then when you multiply 2 times 0, you still get p to the 0, which is still 1. But I want you guys to do what's in parentheses first, okay? Now this one, this is addition, right? But you have this, so the order of operations says do your exponents first and then add, right? So negative 3 to the 0 is 1, p to the 0 is 1, well 1 plus 1 is 2. All right, now these types of problems are the ones that lots of you really messed up on. So this is like, H is like combining concepts 10, 11, and 12 together. So when any of the rules are happening at the same time, you follow Pemdas. So really, I want you to simplify what's inside the parentheses first, and then simplify the rest. So when I go to do example 12, and I know I didn't number these right, so I apologize. When I go to do example 12, before I bring this 2 into every single thing, this problem is going to be made easier if you just combine all of the stuff inside the parentheses first and then square it. Like, it's like doing what's inside parentheses before you do the exponent on the outside. That's exactly what we're doing. We're following the order of operations. So I'm going to multiply the negative 3 times the 4, and I'm going to get negative 12. And then I'm going to multiply my c's together. Just, you can do d's first, but I like to go in alphabetical order. So I'm going to do c to the 4th. This c has an exponent of 1 on it. So that's a total of c to the 5th. And then I'm going to do d to the negative 5th, d times d, and that's like a d to the 1st. So that's going to give you d to the negative 4th. Now the entire thing is being squared. So at this point, if you want to bring in the 2, you can. If you want to deal with the negative d to the negative 4th, you can pop that downstairs as well. It doesn't matter at this point what order you go in. But now, imagine that 12 has a little exponent of 1 on it, so I'm bringing this into everybody. You could pop the d downstairs first if you want. So I'm going to do negative 12 to the 2nd, which is 144, c to the 10th, d to the negative 8th. But now since this guy is still negative, it has to go downstairs. So my answer becomes 144 c to the 10th over d to the positive 8th. All right, the next one. Do what's inside parentheses first. So I'm going to combine all this together first. So I'm going to put my a's together to get a to the 10th. So I'm going to have 2a to the 10th b. That whole thing is being squared. I'm going to now go over to my other set of parentheses, put that together. So I'm going to have in parentheses 3, a to the negative 3rd, b to the 0, that whole thing to the 3rd power. Now you know b to the 0 is 1. This is going to be a 1. That whole thing is a 1, and 1 times all of that is just going to give me 3a to the negative 3rd. So go ahead and cross that b to the 0 out at this point. You don't need it, okay? So now I'm going to bring that 2 in. So this 2, the first 2 has an imaginary 1 on it, the b has an imaginary 1 on it, and now you're multiplying your exponents as you bring it in. So 2 to the 2nd is 4, a to the 20th, because we're multiplying, b to the 2nd. Now if you, all right, now this next part, if you want to deal with a to the negative 3rd and put that downstairs, you can, but I know I'm going to have to combine this over here with what I have here, and I already see an a there, so I'm hoping that when I do that, my negative exponent is going to go away, so I'm not going to do that. I am going to bring the 3 in, and imagine there's a 1 here, so I'm going to do 3 to the 3rd power. Now be careful, 3 to the 3rd power is not 9. 3 times 3 is 9, times another 3 is 27. A to the multiplying exponents, negative 9th. So now let's multiply these two things together. So I'm going to do 4 times 27, which is 108. And I was correct. When I combine a to the 20th with a to the negative 9th, I add the exponents, and now I have a to the positive 11th. And then I've got that b squared. And there's your answer. All right, example 21. So now, before you bring in the 3, what do I want you to do inside the parentheses? I want you to reduce first. I don't want you to do 16 to the 3rd power and 12 to the 3rd power. I don't know what that is off the top of my head. I want you to be able to do the problems off of the top of your head, really. So let's simplify the inside first. Always, 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 always. So reduce 16 over 12. Well, 4 is divisible, goes into that. So 16 divided by 4 is 4, 12 divided by 4 is 3. So it's 4/3. Go ahead and cancel out the y on the bottom and have y to the 5th at the top. Now the whole inside is fully simplified. Your life is so much easier now. Now take the whole thing to the 3rd power. So imagining there's little 1s on the 4 and the 3, when I bring that guy in, multiplying the exponents, you now have 4 to the 3rd power. Well, 4 to the 3rd power is a whole lot easier than doing 16 to the 3rd power, right? That gives me 64. Multiply your exponents, y to the 15th over 3 to the 3rd power is 27, not 9. There you go. The next one. Let's simplify the inside part first. I know a lot of you look at that negative 4 on the outside and immediately flip it. Technically, you're allowed to do that, but I think the problem's going to be easier if we are just consistent and we deal with simplify the inside part first. All right, so I'm going to make a fraction bar. I'm going to put that negative 4 out here so don't forget about it. Make my fraction bar. 15/30ths. That's 1/2. So I'm going to put 1/2 there. A to the 6th and a to the negative 3rd. Let's put this upstairs. When I do that, it becomes a to the positive 3rd. A to the positive 3rd. I'll write it over here. That I'm going to combine now with a to the 6th. That's a total of a to the 9th. And now this j to the negative 2nd, put it downstairs. Combine it with j to the 8th. Remember, when you bring it downstairs, it goes positive. 8 and 2 is 10. So I get j to the 10th. If you went ahead and just subtracted exponents, you could do that. Like if I subtracted the exponents on a, 6 minus negative 3 is positive 9. But then when if I were to do the j's, -2 minus 8 is -10. So if you subtract and you get a negative, that means it goes in the bottom. Okay? So now the whole inside is simplified. Now I'm going to deal with this guy. To deal with that -4 on the outside, flip it. So I'm going to flip this. When I flip it, now I have 2j to the 10th that goes on the top. The bottom, I'm going to get rid of the 1 and just have a to the 9th. Now the whole thing is going to the positive 4th power. So imagine this 2 has a little 1 on it. I'm going to do 2 to the 4th power, j to the 40th, and a to the 36th. 2 to the 4th power is 16, j to the 40th, over a to the 36th. And there's your answer there. I hope that helped. Let me know if you found any mistakes in the video, or let me know if you're confused about anything.